Assalamu alaikum. Today the topic which we are going to discuss is Bronsted-Lowry concept of acids and bases. Actually, first of all, you should know some background. Bronsted was a Danish chemist while Lowry was an English chemist. They individually presented concepts of acids as well as bases. And this theory or this concept is now called Bronsted-Lowry concept. Their concept was based upon the transfer of proton. Now, moving toward their definitions, according to Bronsted-Lowry concept, acid is a substance or a molecule or an ion that can donate a proton to another substance. It means if you have an acid, it will have tendency to give proton to other species. While base, base is a substance that can accept a proton from another substance. Acid is proton donor, while base is proton acceptor. Moving toward examples. Number one, HCl, hydrochloric acid plus ammonia. They react reversibly and goes to form ammonium ion NH4 positive plus Cl negative chloride ion. In this example, HCl hydrochloric act as an acid while NH3 ammonia act as a base. Why? Because HCl loses its proton and converted into Cl negative ion while NH3 accept that proton and converts into ammonium NH4 positive ion. Next example, when we react HCl with H2O, HCl again loses its proton and converts into chloride ion Cl negative, while H2O here acting as a base. Why? Because it accepts proton from HCl and converts into H3O positive hydronium ion. In this second example, HCl is acting as an acid while H2O is acting as a base. Bronsted-Lowry give concept of conjugate acid and base as well. According to them, conjugate acid. Conjugate acid is a species which is formed by accepting a proton by a base, while conjugate base is a species which is formed by donating a proton by an acid. It can be explained with an example. In this example, CH3COOH, which is acetic acid, when reacts with water H2O, acetic acid loses its proton because according to Bronsted-Lowry concept, acid is a substance that has tendency to lose its proton. You can see that if CH3COOH is acid, it has lost its proton and converted into CH3COO negative or acetate anion, which is called conjugate base. While talking about water, H2O, water here acting as a base. How? Because water accepts the proton and converts into hydronium ion H3O positive. It means when a base accepts a proton, it is converted into conjugate acid. And when an acid loses its proton, it is converted into its conjugate base. Acid form conjugate base and base form conjugate acid. Amphoteric species. Some substances which can act as an acid as well as bases are called amphoteric. A typical example is water. For example, when we react in first reaction, you can see that when we react water with ammonia, reversible reaction, water is converted into its hydroxyl ions. It means it has lost its proton and ammonia has gained that proton. Number 2, in the second example, when H2O water reacts with acetic acid CH3COOH, reversible reaction, water accept proton from acetic acid. It means in the first reaction, water is acting as an acid because it has tendency to lose its proton, while in the second example, water is acting as a base because it has accept a proton. The species or the substances which can act as acid as well as bases are called amphoteric. So, water is the typical example of amphoteric substances. Just like Arrhenius concept, Bronsted-Lowry concept has also limitations. Two important limitations have been observed. Number 1, actually, Bronsted-Lowry concept or theory is not applicable to those acids which do not have ability to donate proton. Still, they are acids, but they don't have ability to donate or to give proton. For example, SO3. It is also acidic in nature. When it reacts with water, H2O, it will form H2SO4. It means the nature of SO3 is acidic, but it do not have tendency to donate proton. It means Bronsted-Lowry concept is not applicable to those acids which do not have ability to donate proton, but still they are acid. Number 2, Bronsted-Lowry concept or theory is not applicable to those bases which do not have ability to accept proton, but still they are bases. For example, calcium oxide. Whenever we react calcium oxide with water, it will produce calcium hydroxide, CaOH twice. It means the nature of calcium oxide is basic, but it has not ability to accept proton. It means these were the two main limitations of Bronsted-Lowry concept. And Bronsted-Lowry concept has only focused on the transfer of proton. According to Bronsted-Lowry concept, acids are only those species which have ability to donate proton, while bases are those species which have ability to accept that proton. Thank you.